Hey guys, it's been a while since my last video, but I wanted to shoot a new one on some of the improvements and things I've been working on. I took a little break for hunting season and Thanksgiving, but now the weather started to kick in here in California and gives me more time to be out in the shop and to tinker and to invent. So today we're going to be talking about what's in the box. This is the box. Well, this is the new version of the box that I've been working on, and to show you side by side with the old electronics enclosure, it looks like that. So you'll see there was no way we fit those TB6600s in there. So we have something a little bit newer and experimental still, but wanted to share it with you. It's a little cheaper to build and seems to be working pretty well for me so far. I've run probably 15,000 pieces of 45 through and worked out a lot of the little issues, and we'll talk about that. But it seems to work pretty well, and I think it's a good solution. So let's dive right into it. Okay, we're going to open this up. If I get the right bit. So I found this box was a little bit too small, and I've created another size, a little bit bigger. So you can see it gives just a little bit more room. And what I'm going to do is take the components out, we'll look at that, and then I'll go ahead and transfer them to the new enclosure. We'll get our first look inside. So we have a cooling fan, as you noticed. And there's our USB port. And then we have our electronics and then a couple of connectors. And that's the basics of it. Let's go ahead and disconnect the sensor and the motors. So on the sensor, I wired up the homing sensor, and I'll talk a little bit about that later, but I wired that up to have the sensor and then the 5-volt separate. So it's connected to the same wire, but I split them out because they didn't have all 3 pins together. Then my 2 motor connectors are standard. All right, so from here, what we have is our board has a power input, so we'll go ahead and take that off. So we have our positive and negative. This is our high voltage, our 12 volt. You can see that connects directly to the fan, and I've just sort of have those taped up. You know, I think I soldered these, but let me get rid of this tape and desolder those connections. All the 12 volts went together and all the grounds went together. Okay, so I have the wires desoldered. We can take it apart now. Here's our fan. So we've got to take the buttons off, and I don't know if I need a pair of pliers for that. No, it looks like I can do it without it. Those will just push out. Button and the power connector. Of course, I think I soldered those together too. Yes, I did. So I'll have to pop that out. So you can see how that's kind of a tight fit, and that's why I've tried to expand the box a little bit. I had to actually, the pins here were so close, I had to bend some of them so that they didn't interfere with the pin connectors, or they didn't interfere with the power source. So that's the electronic package. It's just one really nice piece. These are the new motor drivers. These are the A4988 motor drivers, but you can also use the more powerful DRV 88, what are they, 8825, I think. I think usually they're different color, like purple. Anyhow, I haven't had too much problem with these. They've seemed to work pretty well once I've got the reference voltage adjusted. So this is a shield. Might actually be easier to take the motor off first, or the fan rather. The fan is a 40 millimeter fan. Also, I'll put that information in the description, but I think the better place to look at is on GitHub, in the GitHub project. All the information is there in the README for that, which I'll put a link to. All right, so this fan uses 3 millimeter M3 screws. It has recessed places for the nuts, the M3 nuts. Put those to the side. All right, now we can get to the board. So this is an Uno with the shield. So I'm taking off the shield part right now, which is this element. And this whole thing comes as a package from Amazon for 25 bucks. You can get the Arduino Uno, the shield, and 4 of these A4988 drivers. So the Arduino in there has a couple, I put 4 screw holes, but I'm only using 2 of them. Seems to work pretty well. Okay, so you can see there's the mount points, and this is, I think this was about the 3rd or 4th revision. The original ones, no fan, no hole for the fan, and way bigger mount points that interfered. And then still so hole for the fan, but no guard and bigger points. So 3rd try was a charm, almost, except it was such a tight fit I decided to do a number 4, which is this guy. So same thing, I've just added a little bit more room, so hopefully this all works out. But let's talk about the electronics first before we get into putting it back in the box. I think that part's pretty obvious. Let's talk about how we set this up. So the motor shield, in this orientation, you should see these adjustment potentiometers here and here. These should go down for the A4988, but if it's a DRV8825, the potentiometer should be on this side. So that's sort of the orientation that we're working with here. And then we're using the Y plus for our Y plus and ground for our sensor, or for our homing sensor. And so white goes on plus, and black goes on ground, and then we're running the red wire from the homing sensor over to the 5-volt connection here. I suppose I could have used the 5-volt connection here as well, but I used that one. So this sensor, or this shield, just really connects to the Arduino well, if I get it lined up like that. So it pops in. These little motor shields, they just pop right in. And they come pretty much like this. You have to put the heatsink on. It's really just got some sticky tape, and you stick it on top of the processor there. So if they burn out, they're really easy to switch out. And they come with 4. One of the ones that they shipped to me was defective. I threw it to the side and put a new one in. But anyhow, this is enough to sort of experiment with. So from here, we can go ahead and hook up our cables. I mean, the enclosure is nice, but you don't have to have it. All right, so we can hook up our cables. So the motor connectors for this driver are here, and for that one is in the middle, so they're kind of hard to reach. If your motor is running backwards, you can just flip the cable around. In my case, I found, I think, the black wire in my cables went to this edge. And let's see. I'm going to leave the shield off for now. But we would just need to connect power. And I have my power connector somewhere. Make sure that's the right one. Yep. So it's really handy to get as one of these things. I don't know what it's called, but it's come with a few different things. I think you can buy these. It's just a 12-volt connector, but it allows you to connect it to your power supply and then just hook it straight here, which is all we'd have to do. Let me try to do that real quick. Okay, my black wire went AWOL on me, so I decided to use green in honor of the Christmas season. And we can just connect that up here. Now, one thing to note on this, and I possibly burn out my first motor driver, was you're not really supposed to plug these in when there's power. So you want to make sure you get everything kind of hooked up before you connect your power up. So at this point, I do have my power connected. And if I connect this up to my laptop, I will get, I should be able to run the motors here. So let me just grab the laptop real quick. Okay, we have the laptop. I've connected a USB cable, and I'm connecting that up here. If I can find the right hole. Oh, and we just heard the nice click out of our motors. So at this point, I'm going to lose those here. Put those there. At this point, I can run from the Arduino console, or from the serial monitor. I should be able to run the motor. Okay, you can't see it, but this thing is going wild because obviously I did something wrong. So what I'm pretty clear that I did is I hooked the sorter motor to the feed motor, and so I got them backwards. And I'm wondering how long it will run for. It's probably going to run indefinitely because I have homing on, and I was going to talk about that, and there's no homing sensor here. So I think the easy way is just to power this thing down. And we'll disconnect our power. And now I will switch the two motor drivers. Now if I did that right, looks good. And because I do have the homing, auto homing enabled, I'm going to go ahead and hook this up. And plug this into 5 volt there. Okay, if that's hooked up correctly, when I plug this guy back in, I will see my homing sensor has a green light, which it does. All right, so now I'll put my power back on, and I'll pass another 1, which is what we're doing here in the serial console. 1. Oh, I think I need to reconnect it. Okay, I'm back, and now I have the power hooked up correctly. We've got our wires set up correctly, and we've plugged into the laptop, and we've hooked up the serial monitor, which you can see there. So this is running a different version of the Arduino sketch. It's called the Uno Shield version. It's also there in the GitHub project. It has some different functionality. For one, it's set these only support 16 microsteps, the drivers, so I've adjusted the microsteps in the software for 16, but also I've done a little bit more around the auto homing. So let's go ahead and fire it off. I'll just add a 1 in here, and it's running like a charm. Okay, so I didn't hook my feeder up, my Dylan feeder, but you can see as I feed here, if I do so, I can manually control it all from this console by sending the slot number 1, 2, 3 through 9 and hitting enter, and that will actually give me a response like this. So that's the simplified electronics package. These don't really, I mean, they get warm, which is why I put a fan in there. I think it helps it. But like I said, I ran a few thousand through it once real fast, and it worked just fine. No issues there. The one issue I had was when I was running the software and I was combining the Arduino and the camera on this little USB hub, 2-to-1. The Arduino would start resetting every couple minutes, and what I figured out, it must be a voltage thing, but I put the Arduino to a dedicated USB port on the laptop and hooked the camera to the other USB port on the laptop, and it worked fine. So I'm not sure exactly what that was, but I'm guessing that this draws more voltage than the laptop was willing to give on one port to both the camera, the light inside the camera, and the control mechanism here. So that was the only issue I ran into there. Now let's go ahead and see if we can get it put into the new enclosure. Okay, so I disconnected all the wiring, but we need to remove the shield, the top shield, when we're putting this in so we can put our screws in. Really, I just put the USB port in and then line up the holes. These are M3 screws. I have a couple of those little guys here. Let's see if I can't get that in there. I mean, these, I guess you could put all 4 screws in, but really we're just trying to avoid the thing moving when we're putting our plugs and plugging and unplugging stuff. Now that one's a hard one, so definitely a tight space to get into. So if you're like me and you have big fat hands and fingers, that might be a hard screw to get in if you don't have a magnetic screwdriver handy, which I don't. So what I'm going to do is cheat a little bit. Put the screw in there first. Okay. Then we can put our back screw in. Come on. All right. They don't have to be super tight. I mean, it's not really going anywhere. At this point, we can put our motor shield in, and we just need to make sure that we get the pins lined up. I just try to pick an edge that I can see the pins on. It's kind of hard to see, but you'll have to trust me that I did that right. So I push that shield in. Before I put all my other wiring, I guess I could do that now. On the subject of making your own connectors, you need a kit like this. I'll try to put a link to it in the description, but it has the different size of connectors and the pins. And then it's helpful to have a tool like this to crimp these onto the wires. Definitely makes it nice though. I had to do that for the sensor because it came with a 3-prong connector and I needed 2 in 1. So those are the wires, and I've kind of built this gap there that the wires will go through. We have to put our fan in, and that's a pretty simple operation. Usually you can put the nuts inside of the fan. It has little holes for the different nuts. And then you just have to kind of get your screws through. It's helpful if you hold the nut, otherwise it will just push right back out when you try to screw your screw in. And there may be a question about which direction the fan blows. At this point, it's actually blowing out that way. That's just the orientation of this fan. I tried reversing the wires and it didn't change the direction that the fan was blowing. I thought it really should have, but I guess it didn't work that way for me. But it doesn't really matter because I've created vents here. So if it creates a suction, it's just going to pull air through it either way. You're just trying to get air through the box, whether you're pushing or pulling. So at this point, what we're doing is we just have to connect our power button and our power connector. I'm going to go ahead and put the power connector through first. Don't forget to put our nut on it. So it looks like I could have bumped that connector over and given myself a little bit more room to work with. I may adjust the model a few millimeters. This is my first time working on this one. Let's see. So we could probably come over a good maybe 5 millimeters. All right. And then we'll put our button in. It should have a nut if I didn't lose it. There it is. Okay. I'll probably have updated the model before I publish this video, so you'll have more space than I have. Yeah, that's right up on that fan, but I think it'll be okay. I'm sure I'll end up pushing both of those forward about 5 millimeters, and that still gives me plenty of room before I run into my pin connectors. The other thing I didn't like before was I wasn't able to take this stuff out once this was in, so I don't want to be over the top of that where I can't switch these boards out without unsoldering and disconnecting, which is why I lengthened the box a little bit. So what we're going to do here is we'll solder our power back on to the power button. Solder's too far away here. Okay. So power comes in, goes to the hot side, the 12 volt side, or I should say the positive side, goes to the button and comes back out. And then we're going to join all of these together. So our 12 volt, we have a 12 volt fan, and we'll need a 12 volt lead that comes directly from the board as well. And I don't know what happened. Oh, there's my piece of black wire. So I'm going to hook up this, the ground and the positive to the power input on the motor controller. Oh, somehow I missed it. That probably would have been a better thing to do, hooking these wires up when it was out of the box. Let's just see a little better. But at this point, all we have to do is connect all of our reds and all of our blacks. And we're in business. So I'll go ahead and solder those up. I think the best thing would be to have a little wire nut, but I didn't have one handy with me. Somewhere in this shop I have a box of wire nuts, and I looked for them unsuccessfully. Okay, after a little bit of poking, I found that the fan wire wasn't well soldered and it was shorting out. So the fan is now working. Motors are coming on. We should be able to do our test here. I'm going to put a 1 into the machine. And it's in fact feeding. Before we put the lid on, let's talk about reference voltage. So the motor drivers do have to be configured. The A4 9/8, these guys. And so what you have to do is get those set up so that they're producing enough voltage to move your motors. So what you need for that is a multimeter and a small screwdriver. Okay, the 2 points we're going to be testing with the multimeter, well, now I can't see the multimeter, oh well, is the negative lead here, and then the actual screw, the adjustment potentiometer here. I don't know if we're going to be able to do this without blocking the camera here. So you can see I have 710 on that one and 13 on that one. So as you turn these little potentiometers, that reference number will go up and down. So clockwise makes it go up. If you go too high, it kind of stops, or you get too much voltage and these guys will burn out. So I found 0.7, 0.8. It seems to do the trick. I might have to turn it up a little bit more, but so far that's about the setting I've been using. Now these are M4 screws. Okay, funny thing, I was trying to figure out why I was fighting these screws so much, and I took a better look at it and figured out that I actually already made the new enclosure. So this version had the M4 screw holes, and the new one has the M3, which is why I was having a hard time putting those in. Sometimes I'm losing my mind. So M3 screws, not M4 screws, unless you really want to like force them and end up cracking your enclosure a little bit. Let's see. So that's it. That's what's in the box. Okay, well that concludes the coverage of the new electronics and new electronics enclosure. I mean, I think you'll agree looking at these two, this one's a little cleaner, but you know, I think you're going to get maybe better power and reliability out of the old setup with the TB6600s. One more thing I want to cover before we go. In the video I mentioned several times we'll talk about auto homing. So I want to jump into that a little bit. For those of you who are interested, stick around. We'll go in and dive into the Arduino code a little bit and talk about auto homing, which is a newer feature that I've been working on. All right, so in the Arduino code, there's an option which I think is generally set to false, but if you want to use it, I'll show you how to do that. So it's called auto homing equals true. If you set it to true, then what we do is we'll automatically move, in every cycle, will automatically move the brass or move the wheel to the homed area using that homing sensor. So there's a couple features here. One is the homing sensor power, and then we have the homing sensor itself. So as long as you connect those on the device and in the correct pin slot location, then we'll be okay. Setting that to true. There's another option down here which we have called homing offset. And what homing offset does is it says even though your homing sensor has come on, maybe you want to go a bit further. And so that will take you 7 steps beyond where the homing sensor clicked on. And so I created a video and I slowed down the whole process. So you can see there's actually 3 stages. There's the primary feed stage in a single feed, which is the number of feed steps. And then you have the homing steps, which take you up to the point where the homing sensor comes on. And then you have the offset steps. And so this video here shows that. As you can see, it goes very fast, it slows down, and then it slows down a bit more. Now I did that on purpose just to kind of demonstrate those 3 stages. So what I did here is I actually set the feed steps. 80 is the right number of feed steps in my setup, but I set it to like 50, so that it would then take another 30 steps of homing and then the offset steps very slow. So that's how those work, and ultimately it will keep your providing your sensor set up right. It will keep everything in sync, and you won't lose. Even if you lose steps, you end up being okay. I find for this to work well, you probably want to set your feed steps lower than the number of steps in your cycle. So if you're doing 80 steps in between cartridges or in between the holes, maybe set it to 70, maybe set it to 76. You could even set it to 50. It will work either way if the sensor is set up correctly. I found that I had to bend the arm on my sensors to get good contact. I need to come up with a better way of making the sensor more adjustable on the base unit, but I haven't done that yet. So in the meantime, I just kind of hold the sensor, click the arm down and bend it out so it makes good contact with the wheel all the time. And then I can use these two options to adjust those settings. So I want to say a special thanks to Seth, the other Seth that's on GitHub, who's been organizing everything, making the project much easier to use. Really appreciate that. Go check out the work he's done to kind of make the project easy to replicate. Carl also has contributed quite a bit, and actually Carl has contributed a better design for the enclosure, this enclosure that's available there. Check out what's in those experimental folders, and I think you'll see there's a new design for this. I haven't got to print it yet. Definitely will be checking that out as well. Thank you, Carl. I wanted to talk a little bit about kind of what else I'm working on and what's coming next. One of the issues I've seen as a big problem is that as you get going, the camera gets dirty. Dust and debris falls in there. So I've been working to resolve that issue. And so what I have is a new design for a camera module. And it's designed to have this blower. And so the blower will attach to the back of the module like this, and it will kind of create an air shield up across the camera lens, which should hopefully keep the lens more clean. And then I'm getting rid of the threading on the camera module, and we'll just use a set screw on the side. So this will slide up in something like this and be used with the set screw. So I hope to have something working in the next week or two. We'll see. And definitely we'll keep you guys updated on that. But I think this is sort of the real last hardware hurdle is keeping that camera clean. So any ideas you have, put them in the comments. Let me know. Happy to explore any ideas. Well, that's it for today. Thank you guys, and have a great day.